Now dear student, we are going to discuss question. This is question number 2.15, and in this question it is given to you a spherical conducting shell of inner radius r1 and outer radius r2 has a charge capital Q. A charge small q is placed at the center of a shell. What is surface charge density on inner and the outer surface of shell? Clear? So now concentrate on a screen. Now in this question it is given a spherical conducting shell. So before going to discuss this question, let us try to understand what is surface charge density. Surface charge density is defined as a charge this is present on the surface divided by area. Yes or no? So now we can see, let's suppose we have spherical conducting shell. Shell means we can say, let's suppose like this. We can say this is spherical shell. Clear? So this is spherical shell. Now this is spherical shell, it means we can say here we have a conducting body and inside we have a cavity. In this question it is given to you as spherical conducting shell, inner radius is r1 and this value is given r2. Clear? It is having charge q. So we are providing charge capital Q. Clear? A charge small q is placed at the center of a shell. Clear? So now we can see we are placing here a small charge q at the center of the shell. Clear? Now we have to find surface charge density at inner and outer surface. Now dear student, if I assume here a Gaussian surface and this is very close to this cavity. Let's suppose if I am assuming this is a Gaussian surface. Clear? Now we know inside this cavity we have electric field, this is 0. Yes or no? We always know here we always find electric field 0. So when we have electric field 0, so according to Gauss law, clear? According to Gauss law we can say phi net this is equal to q enclosed divided by epsilon naught. Clear? Actually here we write net charge. We write here net charge this is present in a Gaussian surface. Now we can say at the center we have a charge q. So definitely whenever we have electric field 0, it means we can also write like this. When electric field we have 0, it means net electric field lines that is passing through this cavity is 0. So we can say this is equal to q net divided by epsilon naught. Now electric field is 0, so we can say this term becomes 0. So we can say net charge present inside this Gaussian surface this becomes 0. Clear? It means we can say a charge small q that is already present at the center. So we can say an induced charge will be developed at the inner surface of this cavity. Clear? Or we can say inner surface of this conducting shell. Clear? We can say because we have to maintain total charge q. Clear? So we can say total charge that is present at the outer surface this is capital Q plus small q. Clear? If you add capital Q plus q and this is minus q, you can say we are getting answer capital Q. Clear? So actually we also know whenever we are providing some charge to a conducting body, its charge is actually comes to the surface. Clear? Because we can say each charge is having mutual repulsion from other charges. So we can say it will occupy surface area. Yes? So we can say this is the distribution of a charge. Now our objective in this question is to calculate surface charge density. So how can we calculate surface charge density of inner surface? So let's suppose I am taking this surface is 1 and this one is 2. So we can write like this, sigma 1 this is given by q1 divided by area. Clear? Now we can say charge present on the surface 1 this is minus q divided by, because this is a sphere, so we will take surface area of a sphere that is 4 pi r square. So we can write like this 4 pi r1 square. Clear to everyone? Yes. Now if we talk about sigma 2, clear? We can write like this, sigma 2 this is equal to q2 by a. Clear? Value of q2 means we can say total charge this is present on a surface 2. So we can say this one is q plus q divided by, we can say this is 4 pi r2 square. Clear to you? So this is surface charge density on inner and the outer surface of this conducting shell. Clear to everyone? So first part is clear. Clear? Now if we discuss about second part. In this part it is given to you is the electric field inside a cavity 0? Yes, definitely, because whenever there is no any charge present in a cavity, we can say electric field is 0. So definitely this is correct. Even if shell is not spherical but have any irregular shape. Now listen carefully. Actually we already calculated here electric field is 0, clear? So let's suppose we have an irregular shape like this, clear? And let's suppose now we have to find electric field is also 0 in this time. Yes, actually if we talk about Gaussian surface, clear? We can draw any Gaussian surface, clear? Let's suppose in the previous problem we have drawn here a spherical Gaussian surface. This time we can draw any irregular shape, but our main concern is the net charge present in the Gaussian surface, as well as we can say net charge that is present. So whenever net charge that is present is 0, we can say electric field is 0. Yes, so what is the difference in this situation? If we have irregular shape, there may be possibility here we have unequal distribution of a positive charges and the negative charges, clear? But important part is here net electric or net charge, this is present inside any Gaussian surface, we can say this becomes 0. So whether it is a regular or irregular shape object, we can say electric field we always find here 0, clear? So here we will say electric field value is 0, clear to everyone? So this is all about this question.